Thank you.
Oh. Guys, chill. Hey. All right, here we go. The easiest thing that you draw are hydrocarbons, and always the first thing you want to do is count them. So if I drew this one with this many carbons, each carbon always has 4 lines attached to it, and the empty spaces would be hydrogens. So something like this. You've learned some similar stuff. That's a great question. For sure you've seen carbons and hydrogens before, and we've drawn them when we did structures. Now this one has how many carbons? It has 3 carbons, and they're in a row. If they were in a different shape, like if it was this shape, you don't need to draw this shape, but if it was like this, it's still 3 carbons in a row. It doesn't matter if it's like all twisty. As long as you can connect 3 carbons in a row, then you use the prefix for 3, which we already went over, is prop. And then since there are only single bonds between the carbons, then the suffix you use is, if you look back in your notes, the suffix for single bonds is ane, so we call this propane. And literally the word means something very specific. It means 3 carbons, and it means all single bonds. Again, it does not matter if they are in some sort of weird shape. All that matters is that the 3 carbons are connected, and you count them as 3 in a row, so you call it propane. If there was more carbons, and if there was some weird shape situation happening, as you can imagine, that does happen when the number of carbons is more. The chains can twist and be weird. You're drawing every single thing I draw. Are you mad about it?
Yeah.
Okay. Take organic chemistry in college and let me know how it goes.
I'm impressed. My sister's fan. No, she's got a C. That's all she needs. These gets a green carbon.
The 3 C's and all the H's are on it. That's propane.
Yeah, they're both propane. Well, I mean, I didn't draw the C. I didn't draw the H's here, but there are H's here.
Okay.
Anything with 3 carbons in a row is propane. This one does not have 3 carbons in a row. As you can see, it's got 5, I believe.
That would be pent.
And so it has 5 in a row. Does not matter the shape. I could have drawn this in a straight line. I could have drawn it in a vertical line. But as long as it has 1, 2, 3, 4, 5 different carbons in a row, then, and they're all single bonds, so the suffix is ane, so we call this pentane. Okay? Now, pentane, I could also, again, you don't need to draw every single version of it. Here's another version. It's just the 5 in a row. And like I said, as long as there are 5 carbons and you can connect all 5 carbons, we're going to call it pentane. And the A-N-E ending is for all single bonds. I just said that as you add more carbons, the shapes can get more twisty. It's a giant long chain molecule. It does not always actually appear in a straight line like a caterpillar like this. It could be any sort of orientation. And as long as it has the 5 carbons and you compare it to another one with 5 carbons, like these two compared, those are called isomers. Isomers have the same number of carbons, but different shapes. And if this were real college chemistry, organic chemistry, we would get into the differences for isomers because having slightly different shapes does change the chemistry of lots of things. But for us in this class, we're going to treat these as the same thing. Okay, but in reality, they're not because different shapes means slightly different properties. Okay, easy enough, right? When they're all single bonds and all the alkanes with all ANEs, all of these. They are very easy to draw. Just count and then write them. Now, if there's double bonds, things get more challenging. So here's an example with a double bond. Put it over here. And when you draw them, again, remember each carbon needs to have 4 lines. So this carbon right now has 3. So I'm adding my 4th line for it. This carbon also has 3 lines, so I'm adding my 4th line down there. And then you fill in with all the hydrogens. You can practice drawing them in just a moment. Nope. Yes. Bless you. This one is different, as you can see, because it's got a double bond somewhere. And now not only do we need to account for that in name, but also location. That's where a lot of the other rules you wrote down come into play. Say what it is and where it is. And if you're thinking in your head, as some people are, that it's going to be called hexene, that's a great start, right? Because it's got 1, 2, 3, 4, 5, 6 carbons, so hex for the prefix. It has one double bond, so ene for the suffix. But now you need to indicate where that is, because as you can see on here, you've got a lot of different possibilities for where the double bond is. And believe it or not, this actually makes a difference for the chemistry of this molecule, whether the double bond is here or there. Slightly different. So you have to say where it is, and the way that you do that is you number the chain. And you always number the chain in a way that gets the smallest number for this thing that we're interested in. So you can number it either Lewis to Roger or Roger to Lewis, but once you number it, you want to make sure that you give this the smallest number possible. Nice. So you can number here 1, 2, 3, 4 on the 4th carbon, or number it from right to left, it's on the 1, 2, 2nd carbon. You always use the smallest number you can. So if I was going to number this, it would be 1, 2, 3, 4, 5, 6. Now, if there's other things on it, you would keep this numbering system. But for right now, of course, we're just doing the simplest case scenario. So we call this 2-hexene, the 2 indicating where the double bond is. The 2 or the H? Lower. Lowercase. Okay, easy enough, right? So the 2 indicates the where. Oh yeah, I should say this. 2 is the where. Hex is the number of carbons. Ene is the double bond. And, oopsies, and that goes here. They go together, right? The where is the double bond, so it's like saying where it is. Easy. Yeah, Pepe.
Do you use like that try test?
Great, we'll get to in a second. You want to try numbering one of these first? Here's one. No, I hate drawing and doing things. So if you could kindly not, I would appreciate it.
I mean, at least he knows.
What? Second time I used it. Draw this and then see if you can correctly name it. Maybe chat with your neighbor friend after you draw it, see if they have an idea to help you out. It's fairly similar. You always start with the chain, and counting the carbons first is your main goal. So count how many there are here. It looks like 7. 1, 2, 3, 4, 5, 6, 7. So hept is your like root word. Hept meaning 7. And then this is the interesting part right here, the double bond. So number it in a way that gives you the smallest number for that interesting thing, either 1, 2, 3, 4, or 1, 2, 3 if you number it left to right. So 3 is smaller than 4, obviously. So 3 is where it is. Ene for the suffix, because it's a double bond, so 3-heptene. How many had 3-heptene? For the record, for those of you listening to this in 6th hour, my entire 4th hour class had the right answer. No? Specially gifted? That's what you guys are for sure. What if there's more than one? That's what you asked, right, Peyton? Mm-hmm. So if there's more than one, oh, that's fun. Everyone okay?
No, I think how many more of these are there? Just so I know.
3. Should I put them here and here? 3 more of them.
3 more.
3 more, is that too much?
Way too much.
Counting this one. Because it's fat? Thanks. Message received. You think my hand is ugly and unattractive. It hurts you to look at it.
I feel like if we said your hand was attractive, it would be weirder.
No, I think it would be perfect. I would go home and be like, my students think my hand is beautiful. Why don't you, Sarah?
We don't.
Rude. This has 2 double bonds, as you can see. And that is where you, if you look back at the very last thing you wrote in blue on the notes, it says use di and tri or tetra to indicate how many of something. If you have more than one of the same thing, like these 2 double bonds, then you're going to use those prefixes to say how many there are, and then still numbers to say where they are. So, but always start by counting the carbons. This one has 8 carbons, right? 1, 2, 3, 4, 5, 6, 7, 8 carbons. So oct is going to be our root word. And then you just say we got the double bonds, and there are 2 of them. So use the di for the 2, and een for double bonds. So oct. Actually, you add an a here too, because they're in between 2 consonants. So octadiene. Oh, fun. If you don't add an a, it'd be octadiene. I don't like that. Yeah, so if you ever end up with 2 consonants together here between the prefix and the suffix, you usually add an a. That's what we did there. And then you say where they are. Hang on a second. So you have to say where they are. The di means that there are 2 of them. The een means that it's double bonds. And then you say where. Again, you want the smallest numbers possible. So either at 1, 2, and 4, or at 1, 2, 3, 4 and 6. So 2 and 4, of course, is smaller than 4 and 6. So you call it 2 and then 4. You separate them with a comma and then a dash. 2, 4, octadiene is what you would call that little guy. Yeah.
I was gonna ask, like, say like on a test or something, we don't add the a because we don't feel like it.
I wouldn't get mad at you, but you will get used to adding the a because we're going to do a whole ton of these.
Just be very disappointed at them.
I'll be disappointed.
And disgusted.
No. Is that, are you asking if you lose points just so you cannot do it?
Like maybe we forget. Or,
Sure. Things happen. Anything on test it, right? Anything happens. You may have noticed, and thanks for asking, that I put these hydrogens on opposite up and down, or here I went up and down with them. Here's up and down too. You can, in fact, draw them all pointing the same direction. I could take these and move them up. That's a different. We're not going to learn this, but that actually changes the molecule quite a bit. And have you guys ever heard of trans acids? Or trans fatty acids or trans fats. Yeah. Trans fats are the bad ones. Your body cannot break them down very well. Trans is when they are opposite. This actually has a name. And so here, like in the fat, if there was a hydrogen there and a hydrogen here, that's called trans, and it's more difficult for your body to break it down. It's less reactive, as opposed to if they both pointed up, like this. This is called the cis configuration. And then there's more space down here for a molecule to get in. Here, I'll just draw a little face and break down that double bond. And so I found a picture of them if you want to see. Here's an example of them. Of course, I don't know if it's recording this part, but whatever. There is an example of cis and trans. Cis, if they're up on the same side, trans at opposites. Cis, there's more space in here for your body to break this down. And then trans, there's less space, and so your body can't break it down. So trans fats are the ones that are hard to break down. Mm-hmm.
Is that what it is? Yeah.
What happened? I didn't hear you said.
Cisgender and
Yep, named after that for sure.
Definitely relate to each other.
Yeah. One more?
No.
You should practice naming your own, or drawing your own. Sorry, so here's one to draw. I give you a name, you draw it. The name is... hold on, I'm going to draw one. No, I'll just make it up. Okay. 2, 3, 4. Decatriene. There you go, last one. Got one shorter than I promised.
I don't like you.
Try to draw like this. 2, 3, 4, decatriene. See if you can get all the hydrogens in the right spots. Or see if you can get all your armies in the right spots while playing Clash of Armies. So many options. start with how many carbons? 10 carbons. Does it matter if you draw them all squiggly? Not really, but it's probably easier in your brain to draw them in a straight line.
I actually know how to do this. I'm so proud of myself.
It is good to point out, and Kate just mumbled this, but this is dependent of nothing that we've learned this year. So if you have been not into it, mixed results, is that what you said? Mixed struggling. Yeah, then this is something that we can all do based on my excellent teaching and your ability to want to get a grade in here that's above a F. Add in your 2, 3, 4. Tri-E means 3 double bonds. That's what this means. So deca, 10 carbons. Tri means 3 of these next things, and the next things are double bonds. You can name them. You can number them this way or this way. Most of you probably went left to right, but you could also go right to left. There's 2 possible answers here. So I'm going to go left to right. So 2, 3, 4. This is on the second carbon. 1, 2. Easy. 3 and 4. There. Yes. And then you do add the hydrogens back in. Again, nothing there, sorry. Bad, nothing there. Yes, you could. 2, 3, 4. Yep. Each carbon needs 4 lines attached to it, and so these ones here in the middle already have 4 lines. You don't need anything else. There's 4 lines here, there's 4 lines there. You can't add any more hydrogens because you can only have 4 lines. How many of you had something like that, or you're getting on your way to being something very close to that? Oh, again, 100% of the class? Thank you so much. Okay, fine. Bye.